Hi guys, I'm Jenna, and what if I told you that a quarter of the universe is made of something we don't understand, called dark matter? Even though we don't really know what dark matter is, we know that it's there through its effects on gravity. Our first clue that it's there is something called gravitational lensing. Gravity bends light. This so-called lensing effect distorts the image of certain galaxies and tells us that there's something else there that we just don't see. Another clue is that the actual weight of galaxies is much larger than the expected weight. But our understanding of gravity isn't wrong. After all, if our understanding were wrong, we wouldn't be able to put people on the moon or send New Horizons to Pluto. We conclude that we must just be missing something from our model, and that something is called dark matter. We don't know what dark matter is, we do know what it's not. One, it doesn't interact with light. We see things because light waves bounce off of the surface and into our eyes. This is called reflection. However, dark matter does not reflect light, so we can't see it. Second, it's not normal matter, like the stuff that makes up you and me. And finally, we know that it doesn't interact with a special type of field, called an electric field. Electric fields cause certain particles, ones with a property called charge, to change their paths, and if we're careful, we can detect that path change. Unfortunately, dark matter has no charge. This brings up an interesting question. How can we detect it if we don't know what it is? Because of this, there are many competing hypotheses as to what dark matter could be. A popular one, and the one that I'm going to talk about, is called a weakly interacting massive particle, or a WIMP. My research group at RPI is part of a global collaboration called XENON, looking to directly detect WIMPs. According to the WIMP model, when a dark matter particle collides with the xenon in our detector, a flash of light will occur, and our detectors will pick that up. However, collisions of this type are rare. So, in order to make the most out of this, we have to have our experimental facility located about a mile under a mountain and surrounded by lead, plastic, copper, and a tank of ultra-pure water to filter out signals from things we don't want. Detecting the signal is just the beginning, and if or when we think we find it, the result will need to be verified by other experiments. Part of the scientific process mandates that experimental findings need to be verified by other scientists in order to be considered correct. If other groups confirm our findings, then we're in business. If you're interested in learning more about dark matter, check out the links in the description below. Also, thank you very much to Cards Against Humanity for this wonderful opportunity.